This video will give examples on the normal distribution. Draw a distribution for the following data and describe. So, before we begin drawing our distribution, we should make a frequency table displaying the frequency of each of the numbers. So, I'm going to list all of the values and their frequencies. The values range from 6 to 12. And if you go through and count, you find that there are 10 sixes, 8 sevens, 7 eights, 6 nines, 5 tens, 2 elevens, and 2 12s. So now that I have this table, I can construct a histogram based on it. I'll put my values on the horizontal axis, so that'll be 6, 7, 8, 9, 10, 11, 12, and label the axis of the vertical. And so now the 6 is going to go all the way up to 10, 7 will go up to 8, 7, 6, 5, and 2, and another 2. So if we look at this distribution, we can classify it as skewed, because it's definitely not symmetric, and since the tail is on our right side, we can say that it is skewed right. And it's unimodal because there's only one bar that has the highest value. Give an example of a distribution that might be skewed right. So a distribution that's skewed right, remember, has a tail on the right side, and most of the data is clumped over here. So we can think of an example as the number of times that people get married. So most people get married once, meaning our mode occurs right around here at the 1. There will also be some people who get married 0 or 2 times, so there are also many people here. But as you go into the higher numbers of marriages, there are very few people who have been married that many times, so it begins to tail off. An example of a distribution that might be skewed left, so that's something that looks like this, could be scores on a very easy test. So most people will get a range somewhere very close to the 100, and then a couple people will be in the tail here where they get very low scores. A distribution that might be symmetric could be people's IQ scores. The average IQ score by definition is a 100, so most people will be somewhere within that range. And then an equal number of people will fall on either side of that. A distribution that might be bimodal is people's heights. This occurs because there are males and females, and in general, most males will have a higher height, so they'll make the mode over here. And then females will have a lower height, so they'll make a mode over here. The distribution of the cost of an item is normal with mean 50 with standard deviation 5. Draw and label a bell curve for this. So we'll start by drawing a bell curve here. We're going to label the center as 50 because that's our mean. And then we'll go up to 3 standard deviations away from that. So that'll be 55, 60, 65, 45, 40, and 35. And if we recall, we know that 34% of the population lies within this range. 34 here. And then within 2 standard deviations, we have 13.5, 13.5%, and then between 2 and 3 standard deviations we have about 2.35%. And then in the remaining sections we have 0.15% on both sides. So now we want to know the probability that a randomly chosen item costs more than $60. If we look at the distribution, we see that 60 is here. And looking at our labeling of the graph, 2.35% is between 60 and 65, and 0.15% is greater than 65. So if we want the probability that something is greater than $65, then all we have to do is add up 2.35% and 0.15%, which gives us a total probability of 2.5% that the item costs more than $60.